Hi, this is going to be a brief introduction to the idea of optimization problems. Suppose that a farmer has got a field and that farmer wants to enclose as great an area of field as possible in a rectangle, because it's easier to cordon off fields in that way, and they've got, let's say, 60 metres of fence. So in other words, what that means is that the perimeter of this field is 60 metres. So let's write some labels on. Let's call that distance there x, so that's also x along the bottom, and this one up the side, let's call that y. So the perimeter is just x plus y plus x plus y, and we know that that's equal to 60. When we do optimization problems, we always get an equation which is equal to some value. This is called a constraint equation, and it will be used to simplify another equation before we differentiate. What we're trying to maximize here is we're trying to maximize the area of the field. So let's write down an equation for the area. So the area, A, is equal to, well, it must just be x times y. Okay, width times length. Now, if we'd started with this, we can't differentiate that straight away, okay? Because it's a function of two variables, and we're not set up to differentiate things like that at the moment. But if we use our constraint equation here, then we can eliminate one of these variables. So let's rearrange the constraint equation for y. So 2y is going to be equal to 60 minus 2x, so y is going to be equal to 30 minus x. So we can substitute that into the area equation. So we've got x multiplied by 30 minus x, which is 30x minus x squared. And now we've got the area in terms of just a single variable x. So now we can differentiate. So let's do that. So dA by dx is equal to, so 30x just differentiates to 30, and x squared differentiates to minus 2x. And to find the stationary point of that function, what we usually do is we set that equal to 0. And the solution to that is x is equal to 15. Now, what's y equal to? Well, we said further up y is equal to 30 minus x, so y is equal to 30 minus 15, which is also 15. So, in fact, the shape that gives us the greatest area is a square field, which you may have imagined was the case to start with. What we could do, if we wanted to, we could also go back and find out what is the area of the field then. So we'll just take these x and y values and substitute them back into A. So A is equal to 15 times 15, so 15 squared, which is 225 square units.